lot of really interesting information, particularly with Artemis and with STMD. Let's take a look at my notes. So if the community has any kind of input, so I brought up earlier when Marshall was asking about opportunities for the science community. I think we got additional answer when John was talking about the relationship between the science payloads we're going to put on CLIPS versus what would fly on Artemis. But the number that was on that slide was really encouraging: 150 kilograms of science payloads, delivered to the surface for the humans to interact with. So I guess the question I kind of have that's related to that is, how were we going to develop those instruments? Is it going to be entirely through Dolly, or is it going to be through something else? Like LSITP is kind of very specific to take things which are already pretty well advanced and just kind of get them over the hurdle. But it seems like for these science investigations we want to do 5 years from now, there might be some things that are at a lower TRL and need to rapidly rise up to the higher TRL. Okay. All right, Carly.
Okay, I'd like to return to the question that Pam raised earlier this morning, communication. How do we get from where we are now to where we want to be in this decade ahead when we don't have any communication satellites around the moon? That we don't have, in order to be able to transmit the kind and magnitude of data back, the answer was Gateway. There's going to be a excellent, and I know it will be excellent, communication link through Gateway, but that's the only answer I've heard. The current community and population expect not a little fuzzy image. They need a high resolution, high def, color, perhaps even stereo information in streaming in real time. This is a communication link that has to be provided. So I'd like some of the speakers that were talking this morning to give us a little broader background than just it's going to be on Gateway.
You can come up
John's
here.
Coming up there, but before he does, I'll just add that one of the things that we're doing, the Gateway is going to provide X-band, Ka-band capability, also multiple S-band capability. X-band really kind of primarily to get the data up from the lunar surface and those types of things, but we'll also use other and on top of that, we're going to have optical. We're looking at optical capability. I expect optical capability to be there as well, which will really get your bandwidth up dramatically. Followed on by, we envision as industry comes along that they'll support other CubeSats communication capabilities that we'll use either maybe the Gateway as a node or have their own capability to broadcast back. So that's a commercial capability we expect to develop as well. Because we're looking for, I think somebody asked me the question about buying data services, things like that. I expect a global commercial community that if you need data and that need is there and people are willing to pay for it, that somebody be willing to pay for putting a satellite up to communicate that data back and pay for those data services. So that's one answer.
Can I please? So I'm your token international partner. So we're putting together a commercial partnership now with a European consortium who want to put the first commercial communication satellite around the moon, aiming for 2022, with the vision of having a commercial constellation of communications infrastructure around the moon built up over the next decade. And we're currently we're in discussions with NASA and others about how we might partner to make that something that could be provided as an international contribution.
Okay.
And I just want to say about communication, we are studying that because we know that the kind of communication we had during Apollo would obviously not be good enough today, and we all want 4K wonderful imagery of everything we're going to do on the surface. NASA has a group called SCAN, Space Communication Navigation, that looks at the current technologies available to us, and they have a number of different solutions for the communications challenge of communicating with the South Pole, and some are quite elegant and actually could be easily implemented by commercial partners. So we are looking at that. It's not. I believe it's not just going to be gateway. Maybe it will be initially, but there are opportunities for high bandwidth communication systems that are relatively simple to get us very large bandwidths from the South Pole.
Any more on that to answer that topic? Okay, then I'll reiterate
I
something.
do.
Sorry.
Hi, my name is Kelly Larson. I'm here with Aquarian Devices, and I want to say that we're also we are providing what I know to be the first commercial option for a high data capacity, high data rate, low latency, high speed delivery communication system for the moon. So if anyone wants to speak about that, I'm happy to speak about it. And we're very happy to partner with NASA and other government and commercial entities, and are in some conversations about that now. So thank you for asking about it.
Okay.
Pam Clark, JPL. Yeah, reiterating something I said earlier, and I'd like to get in a little more depth to this question. So yes, we do need the infrastructure to support what we'd like to do, the concepts that we have to do the support scientific exploration. But in addition to that, I think, and I've said this all along, we really need some kind of a expedited means for technology demonstration for deep space. It's been something that I think we've been lacking in planetary division of SMD for a while now. And I think it goes right along with facilitating, being able to facilitate everything we want to do on the moon, including, of course, sustainable exploration, but this kind of science we'd like to get from the moon. So I'd like to know what we can do as a community just to get something like that in place. So it has to do with what's going on at the NASA centers and other places as well, which I really believe strongly that we need a tech demo track to complement what we've already got in place for classes A through C, particularly, that'll support this rapid turnaround and incorporating all the advances that have been made over the last decades in materials, in photonics, in optics, in detectors, and as well as in supporting subsystem technology. So if anybody want to contribute to that part of the conversation, I'd be happy to listen.
Well, I guess I'll say something. So we are looking at, what are the technologies we need as we move forward? What do these plans need? What do we need for Mars? What do we need as we go into deep space? Those technology needs to be developed. For example, EDL, we've landed basically about 1.5 tons onto the surface of Mars, and that was 7 minutes of terror. We don't want to do that again. When we're going to send crew and humans and large scientific experiments, we're going to need much more mass capability. So those types of things. So we're looking at our overall plan that I talked about earlier, what's after 2024, how does that fit in with the technology we need developed as well. But we're also looking for commercial folks to come along. There's opportunities. We're trying to develop a commercial capability for deep space, and looking for our partners, our international partners as well, to kick in as well as to how we move forward and address those key points. But you're right on the money. We can't go to deep space and stay there without some technology development, which we need to make sure we infuse.
Okay, great. With that, let's thank all of our speakers so far this morning. And we will get started again in about 15 minutes at 10:30.